Hi everyone, we are going to start our new chapter here talking about quadratic equations, and so today's video is about what is a quadratic equation. We're on page 81 of the binder, and so pause the video, get to page 81, and let's check out these review problems at the top. What is the degree and the name based on the degree of each of the following? 4x plus 7. So this was a polynomial. The degree, we have to remember, is the biggest exponent. And so when I look at 4x plus 7, it's really 4x to the first. So my degree, my biggest exponent there is 1. And when the biggest exponent was 1, we called this a linear polynomial. For b, 6x squared minus 3x to the first plus 11. My biggest exponent there is 2, because it's like x squared, that's the biggest one. The degree name for that was quadratic. Hopefully those are familiar, remember that. And so if we have an equation, so we got that equal sign now, that has a polynomial of degree 2, we call that a quadratic equation. And so we're going to be seeing equations with x squared now. So standard form of a quadratic equation is ax squared plus bx plus c equals 0. And it's familiar in the sense of it's that same biggest exponent first and then work your way down, right? X squared, x, no exponent, the constant. And the key here is it's equal to 0, right? And that's kind of the way we'll think about trying to get an equation into standard form here is to set it equal to 0. So here's some quadratic equations, and what we're going to do is get them into standard form and then talk about finding a, b, and c. So let's look at the first one here. X squared minus 9x equals 4. It's not set equal to 0. I've got to move the 4 to the left side so that it becomes equal to 0. So I'm going to say x squared minus 9x. I have to subtract 4 from both sides. So it's minus 4 equals 0. And so what we do here is we're really lining this up with ax squared plus bx plus c equals 0. So the number in front of x squared, which in this problem is a 1, is my a value. So when I am listing off a, b, and c, I'm going to say a equals 1, and then b is the number in front of x. So that's going to be negative 9. So b equals negative 9. And then c is the constant, the number that doesn't have an x, that's negative 4. A is 1, b is negative 9, c is negative 4. Let's look at 2. For number 2, we have 3x squared equals 6x minus 11. Now, you might think, oh, let's just subtract 3x squared, so then it's 0 equals that. And you could do that. One of the things we like to do for these problems is keep, it's better to keep the x squared term positive. You don't have to, but it tends to be a little easier to do. So I'm going to leave the 3x squared on the left, and I'm going to subtract 6x from both sides, and I'm going to subtract 11 from both sides. And when I do that, now on the left side I get 3x squared minus 6x. Oops, I should be adding 11 to both sides, right? Because it's minus 11, so I should add 11 to both sides. Plus 11 equals 0. And then my coefficients, 3, negative 6, 11, that is a, b, and c. So we would say that a equals 3, b equals negative 6, and c equals 11. In number 3, ooh, it's already equal to 0. Great. But there's no x term. So what we do is we've got that ghost term again. 2x squared plus 0x plus 7 equals 0. We don't really write it normally, but just to think about it, like what is the value of the b in front of x? It's going to be 0. So we would say a equals 2, b equals 0, c equals 7. So if you don't have a certain term, the a value, the b value, or the c value becomes 0. All right, let's look at number 4. 4, I've got 6 minus 2x equals x squared. Same idea here. X squared is positive on the right, so let's move everything to the right side with the x squared. I'm going to add 2x, and I'm going to minus 6. And that way, these all cancel out there. I get 0 equals x squared plus 2x minus 6. And now, remember, when it's just x squared, that means there's a 1 there. So I would say that a equals 1, b equals 2, c equals negative 6. For number 5, similar thing here. I've got x squared, I've got x, but there's no extra number at the end. There's no constant. So we could, again, think of it as plus 0 if I'm trying to write my a, b, and c. A would equal negative 5, b equals 1, c equals 0. Now, we could have moved stuff to the other side so that the x squared would be positive. But if it's already in standard form, if it's already equal to 0, then you kind of just deal with the negative there for the x squared. But in general, it's better to have, if you have a choice, then make x squared positive. Okay, in number 6, what we're going to do is combine our like terms. Let's see, I'm 6x squared and 2x squared. So I want to subtract the 2x squared. That way I still am left with positive 4x squared. And so then I'll subtract 3x from both sides, which, that cancels out, plus 0x. And then I'll add 4, because my goal here is to get everything to the left side. So that would be negative 1 plus 4 is positive 3 equals 0. And so then I can see that a equals 4, b equals 0, and c equals 3. All right, let's take a look at the bottom of the page here. So we've got this equation, x squared minus 3x minus 10 equals 0. And the question says, which of the following x values are solutions to the equation shown below? Well, we know an x value is a solution if it makes the equation true. So really, I'm just checking my answer to see. So I'm going to first, let's do 3 different ones. We're going to check x equals negative 2. We're going to check x equals 1. And then we're going to check x equals 5. So I'll do the first one with you, and then you guys are going to try the next one. So to plug in, to check the answer, we just plug it in. So I'm going to say x squared. So I'm going to go negative 2 squared minus 3 times negative 2 minus 10. Does that equal 0? And so negative 2 squared, notice I used parentheses. Negative 2 squared is positive 4. Negative 3 times negative 2 is positive 6 minus 10. Does that equal 0? 10 minus 10 equals 0. Yay. Smiley face. So the answer here is yes. X equals negative 2 is a solution. So do the same thing. Plug in 1, plug in 5. Pause the video, and then we can check your answers. We'll see if x equals 1 is a solution or x equals 5 is a solution, both, neither. Let's see what we get. All right, see how you did. Did you get no for x equals 1? It is not a solution because it's false. Negative 12 is not 0. But then when we plug in 5, 5 squared minus 3 times 5 minus 10, does that equal 0? It works out that it does. 10 minus 10, 0 equals 0. So I get 2 solutions here. There are 2 values of x that make this equation true. All right, and so a quadratic equation could have 2 solutions. And kind of a thing with algebra is that because it's x squared, degree 2, that's why it has 2 solutions. Now, sometimes it could have less, could have one solution, could have 0 solutions, but it could have up to 2 solutions. So let's look at the next page for a minute. So in this video, I want to give us kind of a big overview of this chapter, and that starts with like what are the methods that we're going to be learning of how to solve: factoring, graphing, square roots, and quadratic formula. Those are 4 ways we can solve a quadratic equation. Those are tools that are going to be in your toolbox for what do you do when you see a quadratic equation, right? And there's one kind of like all-purpose tool called the discriminant, and that's going to help us figure out, it's sort of like a way to help us decide what is the best route to take in solving an equation, which method would be best. Okay, so this is sort of an overview here, and the discriminant is a little thing we can check with an equation that's easy to and fast to do, and it gives us a lot of information. Okay, so the discriminant is just b squared minus 4ac. Maybe you've heard of that before. It's the value of, when we do a, b, and c, we do b squared minus 4ac. And if we check that, if we look at the discriminant, it gives us some information. Okay, so once we put an equation into standard form, right, and we identify a, b, and c, if we get that b is 0 or c is 0, there's that's a really helpful thing. When b is 0, we can solve it with square roots or the quadratic formula. When c is 0, we should solve it by factoring out a greatest common factor. Okay, that's the first thing we look for. Then, if that's not the case, if we have an a and a b and a c and none of them are 0, we can check the discriminant, right? And basically that's going to tell us, does it factor or not? If the discriminant, b squared minus 4ac, is a perfect square, then we can solve by factoring. If it is not a perfect square, then we have to use the quadratic formula. Okay? Notice quadratic formula is mentioned in 3 of these. You can even use it in the 4th one. Quadratic formula always will work, but sometimes there's easier ways to solve. Okay? And we didn't mention graphing, because graphing is something that will also always work, but we're going to focus a little less on graphing as one of our methods. Okay, let's finish off with just a couple problems on the next page. So, which method should you use to solve? Right? Let's just look at each of these problems here, and we're going to get it into standard form. Ooh, look, it is. This one's in standard form. Then we're going to label our a, b, and c. So a equals 1, b equals negative 3, c equals negative 10. Now notice none of them are 0. Okay, so we're going to find the discriminant. And here's how we're going to do that. I'm going to write that formula, b squared minus 4ac. And I'm going to plug in, right? When we do this, I want you to do b squared in your head. You don't even write it down. What is negative 3 squared? Negative 3 times itself is 9. So we're going to write 9 minus 4 times, and then you're going to do AC in your head. What's A times C? What's 1 times negative 10? It's negative 10. And so this gives me 9 plus 40, which is 49. See how this is a perfect square? When it's a perfect square, that means that factoring is a great way to solve this. Factoring is something we were working on all last chapter. Okay, that means this quadratic will factor. Let's look at number 2. In number 2, we have a equals 2, b equals negative 5, c equals 0. C equals 3. Okay, none of those are 0, so let's do our discriminant. B squared minus 4ac. So that's 25. B squared is negative b is negative 5, so b squared is 25, minus 4, and then ac is 6. 2 times 3 is 6, so that's 25 minus 24, which is 1. That's also a perfect square. Okay, so factoring, again, is a great way to solve this one. Okay, what about 4? Let's look at 4. Here I have, it is in standard form, I have a equals 2, b equals 0, because there's no x, c equals 10. C is always the constant by itself, no x. So what did it say on the previous page if b was 0? Pause it and go look back and look. What if b is 0? It said we could solve with square roots or quadratic formula. Okay. So really, I just want to, this part here is to give you an introduction into something that can be really helpful for solving quadratic equations. It might seem a little confusing right now, and that's okay, but it's introducing you to an idea that we will touch back on throughout this chapter. The biggest takeaway in this video is being able to find a, b, and c. Get it to standard form, find a, b, and c. Okay, thanks for watching.